The lesson objective for today is 5.3K. Add and subtract positive rational numbers fluently. To begin with, let's get an understanding of what a rational number is. Remember that a rational number is any value that can be written in fraction form. So of course this would go for any of your regular fractions such as 1/3 or 1/4 or 1/2. But it also includes your improper fractions such as 9/5 or 11 seconds, anything like that. It also includes your mixed numbers such as 3 1/4 or 5 1/3. This includes your decimals as well, as long as the decimal is a terminating decimal, meaning that it has an ending to it, so such as 0.25, because we know that can be converted into 1/4. It also includes your repeating decimals, such as 0.333 repeating. Any repeating decimal can actually be written as a fraction. The example I gave could be changed into 1/3. Okay. The other number that positive rational numbers include are all your natural numbers, or sometimes referred to as counting numbers. So your numbers like 1, 2, 3, 4, 5, those kinds of numbers. Because any of those types of numbers can be changed into a fraction simply by putting them over 1. So for example, if I want to change the number 5 into a fraction, I just make it 5 over 1. So we're going to look at a few examples of problems that involve adding positive rational numbers. So here in this first one, it says 1 week in the month of January, it snowed 0.25 inches, 11/5 inches, 2 inches, and 3/4 inches. The question asks how many inches of snow fell during that week. So beginning, we're going to underline the key information in this problem. So we have this, 11/5 inches, 2 inches, and 3/4 inches. And we're also going to underline the part of the question that tells us what we're doing. So we're looking for how many inches fell during the week. Okay. So when we read that question, we want to devise a plan for how we're going to work this problem. So when it says how many inches fell for the week, that's asking for a total, right? We're asking for a combined total of all the inches of snowfall. So anytime we're looking for a combined total of something, that implies that we're going to be adding the values together. So our plan for this problem is that we need to add 0.25 plus 11/5 plus 2 plus 3/4. Okay, and so whatever that totals out to be, that's going to be the amount of snowfall for the entire week. Alright, now when we look at that problem, it may scare us a little bit because we're trying to add all kinds of unlike forms of these values. We have some decimals, we have some fractions, we even have a whole number in there. And so we're trying to add those together, and that can prove to be very challenging if we don't take this initial first step, which is to get them all in the same form. Now, which form you choose to change them all to, that's totally up to you. There's really two possibilities here. I see that we could change them all to decimals, or we could change them all to fractions. So we're going to actually work it out both ways to see if we come up with the same results. So let's start by changing it all to decimals. So the first value is already done for us. We got 0.25. The 11/5 can be changed to decimal by dividing the numerator by the denominator. So 5 can go into 11 2 times. And so 5 times 2 is 10, so that leaves us a remainder of 1. So then we can either leave that as a fraction if we were trying to make a mixed number, 2 1/5, but since we're trying to make a decimal, we're going to add a 0. So let me show you out to the side what we're doing. This might be a little bit too much to just mentally understand here. So here's what we've done so far. We said it goes in there twice. We had a remainder of 1. And since we're not trying to make a mixed number, we're trying to make a decimal, we're going to add a decimal up here into our dividend, and we're going to bring that down. And so now we're looking at bringing our decimal straight up into our quotient, and how many times can 5 go into 10? And we know it goes in there twice. Okay, which gives us an exact value of 10. So we have no remainder left, so we can stop. So here we got 0.25 plus 2.2. Now, the whole number 2, that really is already in decimal form, because that could be written as 2.0, right? So we're going to just leave that as 2. And then our last one here, 3/4, that's a pretty common fraction. We also pronounce that as 3/4. 3/4 in money terms, we know that's a value of 75 cents, right? So this one is worth 0.75. But if you didn't know that, you could still find it the same way we did 11/5, by dividing the numerator by the denominator. Okay? Alright, so our final step then would be to then add our decimals together. Alright? For some people, this is much easier to do if you line it up vertically, so that all your place values line up. It makes it a little simpler to see what you're adding together. So we can do that off to the side here. Alright, so our first number we have is the 0.25. You can write the 0 out to the front if you like, if that helps. It's not required. What is required is you get your place values all lined up correctly. And then our final number here is 0.75. Okay, so if we're using the standard algorithm for addition, we would just add vertically. Again, if it helps to fill in all these empty spaces with zeros to help you see what it is you're actually adding, go ahead and do that. There's nothing wrong with adding the zeros. It doesn't change the problem at all, and it might make it easier if you see exactly what's being added together. Okay, so I'll show you what I'm talking about just by filling in these zeros. Now you don't have any gaps, and it makes it easier to maybe understand what you're adding together. So 5 plus 0 plus 0 plus 5 is, of course, 10. So we have to carry our 1. 1 plus 2 is 5. And then plus 7 more makes 12. Alright, and then we carry our 1 here. And 1 and 2 makes 5. So we end up with $5.20. Well, sorry, I got a little carried away thinking this was money. This is actually inches of snow. So we have 5.2 inches of snow. Okay, now I said earlier we could have done this problem the other way. We could have changed everything into a fraction and added. So now let's try it that route. So here, the first decimal, 0.25, well, that's pronounced 1/4, right? And 1/4 is the fraction 1/4. And so now we're adding 11/5, which is already in fraction form. Earlier we discussed that any whole number can be changed into a fraction by putting it over 1. So we simply put the 2 over 1. And the last one's already written as a fraction as well, so we can stop. Or just write it, copy it down, actually. Okay. So now they're all in fraction form, we need to add our fractions. Now remember, to add fractions together, we need the same size denominator, right? So that our objects are broken into the same number of pieces. Makes it much easier when we're adding that way. So we had to think about what's a common denominator for 4, 5, 1, and 4. Alright, so there's a couple ways you could figure that out. You could start listing all the multiples of 4 and 5 and 1 until you find one they all three have in common. You could multiply them together. I think the easiest way maybe is just think about your multiples of 4 and 5, because the 1's going to agree with any of them, right? So the multiples of 4 and 5 that they have in common would be 20. So our common denominator for this problem would be 20. So we're going to fill in our common denominator all the way across. And now we're going to simply ask ourselves, what did we multiply by to make this common denominator? So for the first fraction, we had to multiply by 5 to get 20. So we multiplied the numerator by the same value. So 1 times 5 is 5. Second one, we had to multiply by 4 to make 20. So we multiply the numerator by 4, and so we get 44. For this one, we had to actually multiply it by 20, because 1 times 20 gives us 20. So we got to do 2 times 20, and so that gives us 40. And finally, for this one, again, we multiplied it by 5, and so we multiplied the numerator by 5, and we get a grand total of 15. Now that they all have the same denominator, now we can add the pieces together. So if we add the pieces together, we got 5 plus 44 is 49. 49 plus 40 more is 89. And then 89 plus 15 is 104. So we end up with 104 pieces of our 20th size pieces. Now, I would not recommend leaving your answer that way. I would try to simplify it if you could. I can see that both those are even numbers, right? 104 and 20, both even numbers. So why not at least divide them by 2, right? So if I divide both these by 2, half of 104 is equal to 52, and half of 20 is 10. Now you might look at that and say, well, those are still both even numbers, right? So why not divide them by 2 again? I think that's a good idea. So if we divide 52 by 2, we're looking at 26. And if we divide 10 by 2, we're looking at 5. Okay, so now the fraction's fully reduced or simplified, but it's still in improper form. Generally, we don't leave things in an improper form. So let's go ahead and at least make it into a mixed number. So to make it into a mixed number, we divide 5 into 26. 5 into 26 goes in there 5 times, which makes 25. So that leaves us a remainder of 1. So our remainder goes over our denominator. So our mixed number is 5 1/5. Okay. Now the question is 5 1/5 the same value as 5.2? Well, in order to determine that, we would need to convert either the 1/5 into a decimal or change the 0.2 into a fraction. Either way is fine. I might think of the 0.2 as being read as 2/10, right? So 0.2 and 2/10 are the same thing. And then 2/10 is both even numbers on top and bottom, so we can divide those by 2. So it makes 1/5. So I can see that 5.2 is the same as 5 1/5. Okay? So again, what you decide as far as your process, whether you go with process number 1 here, changing them all to decimals, or process number 2, changing them all to fractions, that's kind of up to you. It's kind of where your comfort level is. Which one do you prefer to add with? All right? But in the end, you wind up with the same result. Okay? Okay, so let's look at another example. So in this one it says Daniel had 5.75 yards of rope. He used 7/8 yards, 2 yards, and 9/4 yards. How much rope did Daniel have left? So again, we want to start by looking for our clues. So we know that Daniel started out with 5.75 yards of rope. And then he used these 3 amounts. Okay, so if the question says how much did he have left, then that means they're wanting us to subtract what he used from what he started with, right? So again, we set up the problem like this. 5.75, we're taking away 7/8, and we're taking away the 2, and we're taking away the 9/4. Now again, originally that would be a little tough to do. So step 1 would be get them all in the same form. So I want you to see here's the same 2 processes we did before. Here's process 1, here's process 2. Process 1, we're changing each of these to a decimal and then subtracting to get our final answer. Okay, doing it the same way. Divide the denominator into the numerator to make your decimals. The second route is changing them all to fractions. So same thing, this is 5 3/4, so you could say 5 3/4 and then make it improper by doing 4 times 5 plus 3 to make 23/4. Okay, then 7/8 is already done for you. I would make the 2 into a fraction also by simply putting it over 1, and then you already have the 9/4. So then you got to get a common denominator for 4, 8, 1, and 4. So that would be 8, right? That's the smallest number that both or all 3 of those numbers can divide into. So we change them all to 8. Change our numerators appropriately. So multiply this one by 2, this one by 1, this one by 8, this one by 2 to get our new numerators. And then we're going to subtract these pieces from our total here, 46. So 46 minus 7, then take away another 16, take away another 18. And so we have 5/8 remaining. Okay? Now again, 5/8 and 0.625 are equivalent. You could test that out by either changing the decimal to a fraction or changing your fraction back to a decimal by dividing 8 into 5. Okay? In this final example here, this one you got the first week in February it snowed this much, 11/5, 2 inches and 3/4 inches. The following week it was 3.25 inches. Now you want to know the difference. So again, we want to add these and then subtract this from our total and see what the difference is. This concludes our objective.